Look around you. Today, there is only one species of human on planet Earth, us, Homo sapiens. But it wasn't always this way. For most of our history, we were not the only humans. We shared this world with other, different kinds of humans. And it wasn't just one or two. For a very long time, the fossil record shows a world teeming with human diversity. Then, one by one, our ancient relatives vanished, leaving only us. So what happened to them? The answer is a detective story, and the crime scene is the entire planet. First, meet the most famous of our lost relatives, the Neanderthals. For a long time, we pictured them as brutish, hunched-over cavemen. That picture is completely wrong. That popular image came from a misinterpretation. The first complete skeleton studied was of an old Neanderthal man with severe arthritis. He was hunched because he was in pain, not because his species was primitive. In reality, they were highly intelligent. They were skilled hunters of big game, made complex tools, and had brains that were, on average, even slightly larger than ours. There's strong evidence they cared for their sick and elderly, buried their dead, and even created jewelry from eagle talons and painted on cave walls. They were not primitive, they were just different. And if Neanderthals are our well-known, if misunderstood relatives, our other cousins, the Denisovans, are a complete enigma. They are ghosts of the ancient world. We know they existed almost entirely from a few tiny fragments, a piece of a finger bone and a couple of teeth, found in a Siberian cave. For decades, that was it. Everything we know about them comes not from skeletons, but from the revolutionary science of ancient DNA. Their entire genetic code was read from that single bone. And it wasn't just them. The family album is huge and confusing. There was Homo erectus, the globetrotter who lasted for nearly 2 million years, and Homo floresiensis, the so-called hobbits. And it wasn't just them. The family album is huge and confusing. There was Homo erectus, the globetrotter who lasted for nearly 2 million years, and Homo floresiensis, the so-called hobbits of Indonesia. The planet was a human mosaic. So for hundreds of thousands of years, these different human timelines ran in parallel. We met, we interacted, we lived in the same landscapes, it was normal. Then, around 40,000 years ago, in the grand scheme of things, a geological blink of an eye, they stopped. Suddenly, there was only one type of human left. This is one of the greatest mysteries in human history, and scientists have a few prime suspects. There was no single cause, but a perfect storm of factors. Let's open the case file. Suspect number 1, the climate. The world our ancestors lived in was not stable. It was a roller coaster of ice ages and rapid warming periods, sometimes swinging wildly within a single lifetime. Neanderthals were highly adapted to the cold forests of Ice Age Europe, but as the climate fluctuated, their environment could change dramatically. The forests they knew could turn into open grassland, and the animals they hunted might disappear or move. While Neanderthals were specialists, our species, Homo sapiens, were more like generalists. We were a jack-of-all-trades species, able to adapt to new environments and exploit a wider variety of food sources. Suspect number 2 is simple demographics and bad luck. Genetic evidence suggests the total Neanderthal population was always tiny, maybe only tens of thousands scattered across all of Eurasia. When your numbers are that low, you're vulnerable to chance. One bad winter, one failed hunt, one new disease could be a local catastrophe. For a larger, more widespread population, it's just a setback. Small populations also lead to inbreeding and limited genetic diversity. This makes a species less able to adapt to new challenges, whether it's a changing climate or a new virus. But the timing is suspicious. Neanderthals had been doing just fine for hundreds of thousands of years. Then we show up, and within a few thousand years, they're gone. We were competing for the same land, the same water, and the same food. This doesn't mean a violent genocidal war. It was likely a slow, grinding replacement. Even a 1% competitive advantage becomes decisive over thousands of years. So what was our edge? Maybe our technology. We invented projectile weapons like spear throwers and possibly bows, allowing us to hunt more safely and efficiently than with the Neanderthals, heavy thrusting spears. Another advantage may have been our social structure. Evidence suggests Homo sapiens had larger social networks, trading resources and information over wider areas. This created a safety net that a small, isolated Neanderthal family group just didn't have. This might all tie back to a cognitive revolution. Around the time other humans began to decline, we see an explosion of art, symbolism, and elaborate burials in the Sapiens record. This could signal more complex language, allowing for better planning and cooperation. There's one more suspect in our competitive takeover: disease. When Sapiens moved out of Africa, we may have brought a deadly package of tropical pathogens with us, diseases they had no immunity to. We've seen this happen in recent history. When Europeans arrived in the Americas, the diseases they carried, like smallpox, devastated indigenous populations. The first contact could have been an unintentional plague. So, a perfect storm of climate change, bad luck, and our own competitive advantages seems to have sealed their fate. But the story doesn't end there. In fact, this is where it gets really weird, because it turns out the relationship wasn't always adversarial. It wasn't just competition, it was also cooperation, and even love. When scientists fully sequenced the Neanderthal and Denisovan genomes, they compared them to modern humans from around the world. And they found something astonishing. People whose ancestors came from outside of Africa have Neanderthal DNA. There is only one way that could happen. At some point. And this wasn't a single strange event. Genetic analysis shows multiple pulses of interbreeding, happening at different times and in different places, with both Neanderthals and the mysterious Denisovans. So in a way, they never truly went extinct. They didn't just vanish. They were absorbed. Their populations dwindled, yes, but their genetic legacy found a refuge inside us. This means that for billions of people alive today, there is a ghost in your genes. If your ancestry is from Europe, Asia, the Americas, or anywhere outside of sub-Saharan Africa, you have Neanderthal DNA, typically between 1 and 2% of your genome. The Denisovan legacy is more concentrated. Traces are found in people across Asia, but it reaches its highest levels, up to 5% in populations in Melanesia, like the people of Papua New Guinea. This isn't just a fun fact. This ancient DNA does things. Some of the most common genes we inherited from both Neanderthals and Denisovans are related to our immune system. They gave us a genetic starter pack to fight off local diseases we'd never encountered. Other genes influence how our bodies handle UV radiation from sunlight, our risk for certain allergies, and even fat storage. A special gene variant from Denisovans gives modern Tibetans a crucial advantage for living at high altitudes. So our ancestors got a handy survival kit from their Neanderthal encounters. But this genetic inheritance is a double-edged sword. Not everything they pass down helps us thrive in the modern world. In fact, some of the same genetic variants that once helped our ancestors are now linked to increased risks for autoimmune diseases, blood clots, and even depression. It's a classic evolutionary mismatch. A gene that made your immune system hypervigilant against ancient parasites might make it overreact to pollen in a clean, modern city, causing allergies. The most dramatic example of this came with the COVID-19 pandemic. Scientists discovered a major genetic risk factor for severe cases was inherited directly from our Neanderthal ancestors 50,000 years ago. This single chunk of Neanderthal DNA, present in about half of people in South Asia and 16% of Europeans, tripled the risk of needing artificial ventilation. Why would we keep such a dangerous gene? Because for tens of thousands of years, it probably wasn't dangerous. It may have protected against other viruses, like an ancient cholera. This reveals a profound truth about our DNA. It's not a perfect blueprint. It's a messy, ancient scrapbook, full of adaptations for worlds that no longer exist. Our genome is a patchwork quilt, stitched together from the triumphs and struggles of all our ancestors, including those who were not even sapiens. It's our greatest strength and a source of hidden vulnerabilities. So what happened to the other humans? The verdict is in, and there's no single culprit. It was a perfect storm. Their populations were small and isolated. The climate was chaotic. And then we, Homo sapiens, arrived, with a slight edge in technology, social networking, and maybe some nasty germs. They were outcompeted and replaced, but not completely. In the end, their final survival strategy was to merge with the newcomers. They don't walk the earth today, but they live on as fragments inside our own DNA. The story of the other humans is a humbling reminder. Our species is not an inevitability. We are an accident. The sole survivor of a once thriving family tree, carrying the ghosts of our lost relatives within us. We are not the first humans, we are just the last ones left. The story of humanity is full of strange twists and forgotten characters. If you're curious to learn more about the weird stories hidden in our past, check out our other videos.